Alright guys, let's look at circle theorem today, right? And what is circle theorem? I'm going to be giving you simple tricks on what circle theorem is. What is circle theorem? Circle theorem is basically finding the angle of any or another shape inscribed in a circle. I'm looking for the angle that makes up another shape in a circle. What I mean is, so in case we have a circle, right? Let's assume, sorry it's not drawn to scale, but I tried. This is the midpoint of the circle. Let's just draw any angle in the circle. Let's assume that a shape in the circle. Let's draw, for instance, let's just draw this shape, a right angle triangle. Our job, what we have to do in circle theorem is to look for the angles that make up this shape. Whether it's a tangent, for instance, maybe let's assume we have a tangent, and then they ask us to look for the angle that makes up this tangent. Our job in circle theorem is simply to look for the angles that makes up the shape. Look for the angle that makes up the shape. They can ask you in circle theorem, if this is a shape inscribed in a circle, our job is to maybe find out this angle, look for this angle, look for this angle, or look for this angle, or perhaps look for this angle. We don't know, right? That's the basic thing about circle theorem, is to look for the angles of the shape inscribed in a circle. That's all about circle theorem. And in looking for the angles that make up circle theorem, there are laws. That's why you're seeing the word here, theorem. Laws that makes for easy simplifying of how to find the angles, right? The easiest way for us to find the angles is if we know how to apply the laws to solving this question. If you can just know how to apply the laws, it's easy for you to solve circle theorem, right? And there are basically 9 to 10 laws of how to solve circle theorem. But with this, I'm going to give you easy tricks. I'm going to give you easy patches on how to solve circle theorem problems, right? But before then, I want us to look at basic understanding of how circle works, right? There are lines that makes up circle. We have the segment, we have the chord, we have the diameter, we have radius. I'd like us to look at those things. And I want us to look at triangles, right? Let's look at triangles. We know that the sum of angles in a triangle equals 180, right? We also know that sum of angle in a straight line is also equal to 180, right? If you look enough talk, let me just show you what I mean in the video in the next slide. Thank you guys. Welcome guys. Let's look at this circle for instance. Now look at, this is a circle for instance. Although it's not drawn to scale, but I just tried. Just follow me, right? Now look at this circle for instance. This point is called the middle point. It's called the midpoint of the circle. This point, that is the midpoint of a circle. And I want to show you, any line that cuts a circle that is not from the middle. If a line cuts the circle from the middle, this line that cuts the circle from the middle is called the diameter. Right? Any line that cuts a circle into 2 equal halves is called a diameter. So you're going to buy an orange and then you ask the orange woman after peeling the orange to cut it at the middle point, right? So if she cuts it at the midpoint, it means that you're cutting it at the diameter part because it cuts the circle into 2 equal halves, right? That's what we have here. So any line that cuts a circle into 2 equal halves, that line is known as a diameter. But if it cuts the circle from any point of the circumference, except from the midpoint, if it cuts the circle from any other point of the circumference, that line is known as a chord. Right? It's known as a chord, right? If one cuts at the midpoint, it's called a diameter, but if cut at any other point in the triangle, in as much as it is cutting from one edge of the circle to another edge of the circle, it is known as a what? As a chord. Let's buttress further on what a chord is. So from the chord here, if we have any line from here, if the line is cutting from this side, it's also known as a chord. Right? Even if the line is cutting from this part, in as much as it's cutting from one part of the circle to another part of the circle, that line is known as a chord. Having known this, let's look at what a triangle is. In triangle, I believe we have 3 basic types of triangles. Number 1, we have the equilateral triangle. And what's an equilateral triangle? An equilateral triangle is simply a triangle that has all the sides equal, right? An equilateral triangle, the word equilateral, it means equal triangle, equal length, equilateral, equal length triangle. And this line signifies that this line is equal to this line is equal to this line. That means if this angle is 20, it also means that this triangle should be 20 and this angle as well should be 20. That's what an equilateral triangle means. It means it has all sides equal and all angles are also equal. Right? For an equilateral triangle, the angles that makes up an equilateral triangle are 60 degrees in nature. 60 degrees angle is what makes up an equilateral triangle, such that the sum of angles in the triangle is 180. 60 plus 60, 60 plus 60 plus another 60, all of them will sum themselves to give you 180, and this is a rule in triangle. What of the rule in triangle says the sum of angles in the triangle add up to give us 180, must add up to give us 180. That's number one triangle. Number two, we have what we call the isosceles triangle. An isosceles triangle is a triangle whereby only two sides of the triangle are equal. Only two sides. That means only this side and this side of the triangle is equal. And what does that mean? It means that this angle will be equal to this angle. So when you see a triangle that they have two strokes here, just two strokes, it means that this angle and this line and this line is equal. These two sides are equal. And what that buttresses mean? It means that this angle is equal to this angle, but this one is different from these two, right? So if I have 20 degrees here, it means that if here is 20 degrees, here also must be 20 degrees, irrespective of what here is. Are you getting it? That's the second type of triangle. Number two, third triangle is what we call the scalene triangle. And the scalene triangle is a triangle whereby no sides are equal. So this side is not equal to this side, and this side is not equal to this side. Are you seeing? When I'm putting two strokes here, it means if this one is 1 and this one is 2, that means this two and this one are not equal. If this one is 1 and this one is 3 strokes, that means these two lines, these two sides are not equal. And if this one is 2 and this one is 3, the three sides are not equal. But the three of the angles must sum up together to give us 180, because that's the rule in triangle. So if this, let's call this x for instance, y degree and z degree, it means that x must plus y plus z, they must sum up to give us 180. That's law of triangular angles. That it states that all the angles must add up together to give us 180. That's a short form of what I want to explain for you in triangle. Next, I want us to look at something else. Let's look at what we call angles in a straight line. Sum of angles in a straight line. So look at, this is a straight line for instance. If any line cuts across this straight line, right, it means that this angle here that it forms here plus this angle that it forms here is equal to 180. So if we have this angle, let's call this angle x degree and let's call this angle y degree. It simply means that x degree plus y degree will add up to give us 180. And the reason for this is because we have the angles, both angles are in a straight line. Even if the angles are 3, let's look at this straight line now. And then we have it cutting itself 3 places. This is an angle. Let's call this one x degree. This is y degree. And let's call this one z degree. What does this mean? Since it's an angle, these 3 angles, they are forming in a straight line, it means that x degree plus y degree plus z degree, 3 of them to sum up, and we must surely have 180 degree. So for angle in a triangle, sum of angles in a triangle, they are summing up to give us 180 degree. Also, sum of angles in a straight line must sum up to give us 180 degree. If we have these two things and we know what a chord is, we can simply go to the number 1 theorem and the number 2 theorem, which I'll be showing you shortly in the next video, in the next slide. Only for more, guys. Thank you. Welcome back, guys. Let me show you something about this. Now look at this circle for instance. We said if we draw a line that is not cutting across the midpoint of the circle, we know this to be a chord, right? Now the whole of this part, the whole of this shape, the whole of this part, this surface of the circle is called a major segment. This is called a major segment. And the whole of this part, this smaller part, is called the minor segment. Right? Just understand what segment is. Segment is just a part in the circle, right, that is cutting across line, right? We said this line is called the chord, and the whole of this part is called the major segment, and this part is called the minor segment. And that brings us to theorem 1. It says the angles formed in the same segment are equal. So if we have a circle like this, for instance, we have a circle like this. Just follow me now. Forget about myself. I know my circle is not straight, but just follow me, guys. If we have a circle like this, a circle like this, and then we have the midpoint, and then we have a chord cutting across it, right? And then let's assume that we are forming an angle with this, segment, this part of the segment. Now, what this theorem is telling us that this angle form, in as much as this shape form is in this major segment, right? And then we try to form another shape, right? In as much as both shapes are in this segment in the same chord, this angle must be equal to this angle. Are you getting it? So if this place is x degree, it means that here must also be what? X degree. That's what it means, because they are in the same major segment. Look at, they are in the major part of the segment. They are in this part, not in the minor segment. They are in the major segment. right? So we said for a major segment or for angles formed in a segment, the angles are always equal to each other. If we have angles in the same segment and we are drawing to, even if we want to add another angle, for instance, let's assume we are adding another angle to it, we are adding another shape to it, right? This angle, the angle formed here, must be equal to the angle formed here, and this angle formed here must also be equal to this angle formed here. So if this angle is s degree, it also means that this angle as well is what? S degree, and this angle also is x degree. Sometimes what examiners do is that they remove this segment. That they remove it, it does not alternate the rule. The rule still stands. Even if they remove the chord shown there, know that in as much as they are in the same segment, this angle is equal to this angle, also equal to this angle. Are you getting it? Let's look at two questions to buttress what we just did as regarding to theorem 1. Angles in the same segment are equal. Alright guys, let's take a look at this question, how to solve this question in minutes, in seconds. Right, look at this now. I said calculate the value of the angle QNP. And when you are saying things like this, I know students, they always have questions as regarding to all of this. What does this mean? It means that we should calculate the middle angle. QNP is the middle angle. Whatever angle that is formed at the middle, and the middle number here, the middle alphabet here is what is M. So we are looking for the angle QMP. That means we are looking for this angle because it is Q to M to P. So we are looking for this angle. It is forming like this, right? So the angle this is the middle angle that is forming to this. So the middle angle is what we are looking for. Let's call the middle angle, let's call it X degree, for instance, but we don't know it, and that's what they ask us to calculate, right? Remember we said something from the first theorem. We said angles that are formed in the segment, in the same segment. Look at the major segment now. Two angles are formed, two triangles are formed here. We said if two angles, two objects or two angles are formed in the major segment, what do we have? This angle must be equal to this angle. Are you getting? They didn't give us, but we should know that from the theorem, right? So if here is 42, it means that here also should be 42 degrees, right? But look at now, if you look at this is a triangle, we're looking for, if you look at this, pick our eyes to this part, this is a triangle, right? A right angle triangle. And for that, you know that right angle triangle here is 42. This part should be what? It should be angle 90. Because if you try and take, let me try and isolate this part. If I isolate this part out now, you discover something that this is just a right angle triangle. If here is 42, this angle here is 90, right? And we don't know this angle, so it's easy for us to find this. How do we do that? We know that the sum of angles in a triangle, like I taught you just now, is what is 180 degree. So this one, we add on this angle, we add up with this angle, also we add up with this angle to give us what? To give us 180. This one doesn't matter. We're just using this one to understand that whatever is here is here. But there's nothing connecting us with this. We're just looking for what is connecting the dot with circle geometry, right? So we are connecting the dot, looking for this angle from this angle. We can only get this information from this information. So knowing what is given here, we know that here also is 42. So 42 plus 90 plus x will be equal to 180. And the reason for that is that angles, sum of angles in a triangle is what is 180. So we can, from here we can say 42, that is this 42 plus what? Plus our 90 plus what? Plus our x, which we are looking for, is equal to 180 degrees. The reason for that is that sum of what? This is the short form of angle, right? Angle in what? In triangle. That's the reason, right? So if we sum this, what do we have? 42 plus 90 gives us what? 132. So with that we have 132 plus x is equal to 180. So what do? We collect like terms, right? We collect like terms. How do we do that? We move this 132 over to this other side. So that becomes 132, which is 132 plus x, giving us 180, of which you know what the reason was. If we move 132 to this part, this plus here becomes minus, right? So it becomes x will be equal to what? 180 minus what? 132. And 180 minus 132 give us what? X becomes what? Becomes 48. That's the value of x. And x there is what? Simply the QMP. Therefore, we can say x, which is equal to angle QMP, is equal to what? 48 degrees. That's the answer to this question. So what did we just do? Let me buttress again. They gave us an angle that was like this before, right? And then they asked us to, and here was not given. Right? They just asked us to find the value of x, angle QMP. But how do we do that? Is to know the first theorem that says angle in the same segment are equal. So this angle is also equal to this angle. That was why they gave us this angle. They gave us this information. They expect that we should understand that this angle is equal to this angle. They expect us to understand, to know what it is, right? So if you get this angle, this place is already 90 degrees. So we already have a triangle to work with. This is the triangle to work with, right? So 42 plus 90 plus this angle we are looking for is equal to 180. And the reason for that is that sum of angles in triangles is equal to 180. From there, we'll do our simple math. 42 plus 90 plus x is equal to 180, right? 42 plus 90 will give me 132 plus x, which is equal to 180. If we collect like terms, we have that our x is equal to 180 minus 32, and that gives us what? Gives us 42. I'll show you another question in the next video, on the next slide below. Follow me for more, guys.
Premium Hill Academy. Morality, ingenuity, and excellence at its peak.